We now take up the properties of the hyperbola. First, we define C upon A is equal to A, that is the eccentricity of the hyperbola. Since C is greater than A, C upon A equal to E is also greater than 1. Also, C is equal to AE. Second, we discuss symmetry. Where similar to the ellipse, here also the curve is similar to both, symmetric about both axes. Since every value of x, there are two equal and opposite values of y, and vice versa. Thus, hyperbola is symmetrical about both axes. Third, x-axis intersection. The curve cuts x-axis when y is equal to 0, gives x square equal to a square. That gives x equal to plus minus a. Cuts x-axis at a, capital A comma 0, and a dash minus a comma 0. These points are called vertices of the hyperbola. A dash is called the transverse axis. Also, A dash is equal to 2A, that is equal to the length of the transverse axis. Fourth, we take up y-axis. When x is equal to 0, we get imaginary values of y. Hence, the curve hyperbola does not intersect y-axis. But it being symmetrical about y-axis, it is called conjugate axis of the hyperbola. Fifth point, center. Transverse axis and conjugate axis intersect at the center of the hyperbola, which is origin in this case. Sixth point, the foci. The points S and S dash, called foci, have coordinates as plus minus C0, which can also be taken as plus minus AE0, where A is the semi-transverse axis and E is the eccentricity of the hyperbola. Seventh, the directrices. Two lines parallel to y-axis, that is the conjugate axis in this case, and at a distance of A upon E from it are called directrices. Their equations are therefore x equal to plus minus A upon E. Latus rectum, that is latera recta. That chord of the hyperbola which passes through focus and is perpendicular to transverse axis is called latus rectum. If R is one end of the latus rectum, let the coordinates of R be C, H, because its abscissa is same as the abscissa of focus, which lie on the curve x square by a square minus y square by b square equal to 1. Substituting ch, we have c square upon a square minus h square upon b square equal to 1. That gives h square equal to b square times c square minus a square upon a square. That is b square into b square upon a square, b4 upon a square. Therefore, h is equal to plus minus b square upon a. Hence, ends of the latera recta are plus minus c plus minus b square by a. We can replace c by ae. Therefore, the coordinates are plus minus a, comma, plus minus b square upon a. Also, the length of the latus rectum will be twice the ordinate of r, that is twice b square upon a. Now ninth point is focal chord. Any chord of the hyperbola which passes through focus is called the focal chord. 10th, focal distance of a point. If Pxy is any point on the hyperbola and its distances from the two foci are called focal distances and are equal to Ex plus a and Ex minus a. It must be noted that the difference of these two focal distances of a point is always constant and is equal to the length of the transverse axis, 2a. Now 11th point is parametric equations of the hyperbola. For the hyperbola x square upon a square, y square upon b square equal to 1, the parametric equation is x equal to a secant theta and y equal to b tangent theta, which is denoted by theta, which is also called the eccentric angle for the corresponding point, whose coordinates are a sec theta, b tangent theta. Equation of the chord joining theta 1 and theta 2. The equation of the chord joining P a secant theta 1, b tangent theta 1 and Q a secant theta 2, b tangent theta 2 is obtained by using two-point formula, and we get x upon a cos theta 1 minus theta 2 by 2 minus y upon b sin theta 1 plus theta 2 by 2 equal to cos of theta 1 plus theta 2 by 2.